Welcome back to Math with Rhyme or Reason. Today we're going to be looking at systems of equations and solving them. In order to do that, I'm going to have to back up and talk just for a few minutes about Math 10 solving systems of equations. So in grade 10, you talked about solving systems using graphing, using substitution, and using elimination. So I'm just going to do an example of each as I'm going along and then bring it into the grade 11 curriculum at the same time. So in grade 10, you started with solving systems of equations using graphing. Now this was the method that all of you wished you didn't have to do, but you do. So here we go. So I'm going to graph the green line first. In this case, it's pretty easy to see. Your x-intercept and your y-intercept will each be 3, because if x is 0, y is 3. If y is 0, x is 3. So that gives me 2 points on my graph. And of course, as soon as you have 2 points, you can graph your line. All right. With the blue one, you can put it into slope-intercept form if you like, or again, you can look for x and y intercepts or use the slope or a variety of things depending on how you learned it. So for ease, I'll put it in slope-intercept form. Okay, so my y-intercept is -3. My slope is 2. So I count up 2 over 1, up 2 over 1, and I've got a very nice graph sitting here. Okay, and when we solved by graphing, oh, by the way, the answer, of course, is the intersection point, which is 2, 1. When we solved by graphing, we always had nice integer answers. All right, and that's because graphing is not a precise way of solving, and so trying to solve when your answer is in fractions by graphing is really tough. So we always made sure the answers were nice, which is fantastic. So I want to show you a little bit of graphing with the grade 11 where we do not line, but line parabola and or parabola. Now, the easiest way to do this, of course, is with a graphing calculator, and there's lots of information on the internet and or with your teacher on how to go about solving for that, looking for the intersection points, etc. But there is usefulness in knowing how to solve by graphing, at least having an idea of what your graph should look like. So I'm going to do a couple of those as well. I'm going to do a linear-quadratic system, and then I'm going to do a quadratic-quadratic system. Both have nice intersection points, again, because it's graphing, and we want to make sure that our answers are nice. So I'm going to keep my grid here. Now I'll draw it again. All right. So my first example I used was, and again, I'm solving by graphing, so I'll do it with a line, which is x minus y equals 1. And a parabola of y equals x squared minus 5x plus 4. Okay, so I'm going to start by graphing the line, which is easy enough. My x-intercept will be 1. My y-intercept will be -1. My slope is 1, so I can go ahead and count and get my line. Oops. All right. Now, in order to graph my parabola, I'm going to put it in nice form. So this refers back to the previous session where I showed you how to get it into nice form by completing the square. This y-intercept of 4 is also going to help us with the shape and graphing the parabola. So I'm going to go ahead and do that. So I have x squared minus 5x. I'm going to half it, square it, and then since I've added the 25/4, I'm going to subtract off the 25/4. I'm going to add the 4, and what I'm going to do is change that to common denominators just so it's easier for me to add it. You can do it with a calculator too, but 4 is the same as 16 over 4. And then when I add my -25 over 4, and 16 over 4, I get negative 9 over 4. All right, so there's my completed square. And now I have my parabola in nice form. So the vertex is at 5/2, 9/4. It opens up. I have a nice y-intercept of 4. So I can graph it. So it's at 2.5, 2.25. And I know it hits 0, 4, which means by symmetry, it's also going to hit 5, 4, which is up here. All right, so now I can graph my graph. And it does go through there. All right. So by inspection, if I look at it solving by graphing, it looks like it goes through 1, 0 and through 5, 4. Oops. So the way to check, of course, is to plug it into both equations to make sure that your answer works. That is, if I plug in 1, 0, 1 minus 0 is equal to 1. That's fantastic. 1 here, remember that's the x value. 1 minus 5 is negative 4, plus 4 is 0, so that works. Similarly, if I plug in the 5, 4, it will also make it a true statement. So I know that my graph is correct. Let's do one more, solving by graphing, but this time I'm going to make it a quadratic-quadratic and look for the intersection points. Okay, so this one I'm going to use x squared minus y is 0. And I'm going to use x squared minus 2x squared minus 2x plus y equals 4. Okay. So we're going to have to graph both of those and look for our intersection points. So the blue one, again, is easy to get into nice form. That's the same as y equals x squared, which is just our basic parabola. Okay, so it goes through 0, 0. It goes through 1, 1, and negative 1, 1. Goes through 2, 4. And negative 2, 4, etc. Okay, so there's our nice parabola. Okay, the green one, though, we're going to have to rearrange a little bit to get it in nice form. So I'm going to subtract the x squared minus 2x from both sides. So I have y is equal to negative x squared plus 2x plus 4. And again, I'm going to complete the square to put it in nice form so it's easy to graph. So I'm going to pull out my negative. Half squared. I've subtracted 1, so I'm going to add 1. So my parabola is opening down. It's negative, with a vertex of 1, 5. So my vertex is 1, 1, 2, 3, 4, 5. It has a nice y-intercept of 4. Oh, that looks nice. There's one of my intersection points right there. And then we can pick another nice point for it to go through so that we can find where it intersects nicely. But it should go something like so it looks like it goes through 2, 4, and maybe through 1, negative 1. So I'm going to write down my answers. Sorry, negative 1, positive 1. There we go. All right. So, and as before, I can check to make sure that those answers work. So obviously the 2, 4 works. That one's pretty obvious. And then if I plug in the negative 1, 1, it certainly works with this guy. And if you plug it in here as well, you get 1, My plus 2 is 3, plus 1 is 4. So I know I found my intersection points. So that's solving by graphing. And in 1 minute, we'll start into the second part of this, and that is solving by substitution and by elimination. Again, I'm going to review the grade 10 first, just briefly, and then bring us into the grade 11 of solving quadratic and linears or quadratic quadratics using substitution or elimination. See you soon.